Hey everybody, this video is to debrief the activity you did in class today. I hope it helps. If you have any questions, you can post them to the group in Edmodo, or you can jot them down and ask them in class tomorrow. In this video, we're going to review what multiples are. We're going to practice some strategies for generating multiples, and we're going to be finding the common multiples of more than one value. And finally, the realistic problem where this skill comes in pretty handy. Let's start with the definition. When you multiply a whole number by another whole number, including one, you get a multiple. Here's an example. I'm going to draw an apple. I know it doesn't look like multiple apples. Well, but it kind of is, because it is times 1, or multiplied by 1. And here is another apple, and another one. And this is multiple apples. It's times 2, or multiplied by 2. So instead of starting with an apple, say I start with the number 5. 5 is still a multiple of 5 because it's multiplied by 1. And 10 is a multiple of 5 also because it is multiplied by 2. And 15, of course, is a multiple of 5 because it is multiplied by 3. There you have it. So what is a common multiple? Well, let's pick two numbers and make a list of their multiples and see if they have any in common. That show up on both lists. So when we're listing the multiples of 2, we have to start with 2. 2 is a multiple of 2 because 2 times 1, or multiplied by 1, is 2. So then next is 2 times 2 is 4, 2 times 3 is 6. Here's a bunch more multiples, and I put 3 dots on the end to indicate that this just keeps on going forever. Now I've added the first 5 multiples of 5. The next thing that I'm going to do is I am going to circle the multiples in both lists that happen to be in common. So in the first list I see a 10, and in the second list I see a 10. And in the first list I see a 20, and in the second list I see a 20. So the first 2 common multiples in this endless list are 10 and 20. So what is the least common multiple of 2 and 5? Well, least means smallest, and the first 2 multiples of those two numbers are 10 and 20, and so the smallest one is 10. 10 is the LCM of 2 and 5. So let's talk about some strategies for finding multiples. Like making lists is a pretty quick way to find common multiples, but there are some other methods that we can try. So number lines is another one that we could try, and that's a pretty nice visual way of doing it. And hundreds charts are also great because they're also pretty visual. I guess the thing that a lot of people like about the number lines in the hundreds chart is that after a while you kind of forget about looking at the numbers and you just start to see a pattern emerging on the paper, and your pen or pencil just wants to follow that pattern, and it seems to be pretty quick that way. Here's the number line method. I'm looking for common multiples of 3 and 4. All of my multiples of 3 are already listed here. Now what I'm going to do is I'm going to add the multiples of 4. Here we go. 4, 8, 12, 16, 20, 24, 28. If you look at the number line, you'll see which numbers are occupied by 2 circles, a yellow one and a red one. Those ones are common multiples. So now we can list them. 12, 24. So here's a question. Which one is the LCM? That's right. The smallest one, 12. That's the LCM. Hundreds charts work in a similar way. I'm going to show you multiples of 4 and 6. As you can see, multiples of 4 are already circled in yellow. I'm going to go ahead and start circling some multiples of 6, and we'll see where they overlap. So we have 6, and we have 12, and 18, and 24, and before you know it, a pattern starts to emerge, and you have a few squares that have 2 circles on them in different colors. And now you have your common multiples. 12, 24, 36, 48, 60. So now we get to the why should I care situation, the one that you tried out today. It's Nelson 1.1. It's the hot dog conundrum. It's pretty realistic. Here's your scenario. Some grade 7 students are planning a party and they need about 100 hot dogs, and they don't want any wieners or buns left over because nobody wants wasted food or wasted money. The trouble is, hot dogs, you know, the wieners, they come in packs of 12. And the buns, don't ask me why, but they come in packs of 8. Don't ask me why. I think it's just been like that for as long as I can remember, and it makes no sense to me. But let's just deal with it. Essentially, we're looking for common multiples of 8 and 12, and specifically, we want the one that is closest to 100. Now, you could plan on using a list to find out all of these multiples, or you could use a hundreds chart. Since this problem involves counting by 8 and 12 to 100, I think a number line will take up a lot of space. So I think I'll use the list or the hundreds chart. Here are my multiples of 8. And here are my multiples of 12. Now I'm going to circle the common multiples. And I'm going to see if I can find the common multiple that's closest to 100. 24, 48, 72, 96. Voila, there it is. That seems to be the multiple that's closest to 100, so I guess we're making 96 hot dogs. But how many packages of buns do I need to buy? Well, so I go to the 8 multiples list and I count how many packages I need in order to make 96. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I need to make a run to the store to pick up 12 packages of buns. And how many packages of wieners? 1, 2, 3, 4, 5, 6, 7, 8. I need to get 8 packages of wieners. Let's see what it would look like if we were using a 100s chart. You start to see a pattern emerge, don't you? At this point, to find out how many packages of buns you need, count the yellow dots. And to find out how many packages of wieners you need, count the red circles. And that's all there is to it. Hopefully, you now understand what multiples are, you know some strategies for generating your multiples, you can find common multiples, including the lowest common multiple of 1 or more value, 2 or more values, and you now have a realistic problem where the skill comes in handy, and I'm sure you'll be able to apply these techniques to problems that you come across in the future. Thanks.